Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The structure shows a 5-membered carbocyclic ring, i.e., a cyclopentane-based ring. Moving on to the next step. Identify the degree of unsaturation within the ring. There are 2 double bonds visible in the ring, making it a cyclopentadiene framework. Moving on to the next step. A hydroxyl group, OH, is attached to the carbon that is not part of either double bond, i.e., the sp3 carbon. In a cyclopentadiene ring with double bonds at positions 2, 3 and 4, 5, the sp3 carbon is at position 1. And for the final step. A. Parent chain ring, cyclopentane, cyclopenta, 5-membered ring. B. 2 double bonds, indicated by DN with locants 2, 4, cyclopenta 2, 4 diene. C. Principal characteristic group, OH, alcohol, indicated by ol suffix, located at C1. D. Numbering, the carbon-bearing OH gets the lowest possible locant, 1, and the double bonds are then at C2, C3 and C4, C5 giving locants 2 and 4. Cyclopenta plus 2, 4 diene plus 1 ol is equal to cyclopenta 2, 4 diene 1 ol. The OH group at C1 is on an sp3 carbon. 2 conjugated double bonds span C2 is equal to C3 and C4 is equal to C5, consistent with the drawn structure. Therefore, the correct answer is cyclopenta 2, 4 diene 1 ol. The correct answer is shown on screen.